Hello, Miss Walsh here, and today we're going to learn about inverse functions. Before we do, let's just take a quick look at the equation here. This is an equation to convert Celsius temperature into Fahrenheit temperature, okay? So this line is graphed right here. So I'm just going to label the units for this, that the Celsius is on the X, it's the independent variable, and the Fahrenheit is on the Y. So if we wanted to see how much is 20 degrees Celsius, then what we would do is to find f of 20, we would just substitute the 20 in, and then that would get simplified to 4. 9 times 4 is 36 plus 32, it's 68 degrees. So let's just label this point right here. So we know that this point is 2068. Okay, now suppose you as maybe a European or from another country that is used to the Celsius system are traveling in the United States that uses the Fahrenheit system, and you want to convert the temperatures that are given to you in Fahrenheit to Celsius. So how do you do that? Well, the one thing that you do know is that if you have 68 degrees Celsius Fahrenheit, then in Celsius, of course, that will be 20. Okay, so this is a function that has reversed the variables, okay? So as it says here, the input and the output are swapped. And that indeed is your definition of inverse. So the inverse function, and it's denoted by this f negative 1 of x, which you've seen as a negative exponent, but in the case of functions, it has a different meaning. It means inverse is when the independent and dependent variables are reversed. You perhaps, if you are figuring out how much it's costing you to go in a taxi for a certain number of kilometers, right? So kilometers are your independent. Well, perhaps you want to do it the other way around. Maybe you only have 20 euro and you want to say, how far will that get me? So you would swap the kilometers and the money, okay? So sometimes we do want the inverse of that original function. So now how do we find this inverse function algebraically, okay? So I'm going to label this as f of x, and then this will therefore be our inverse f negative 1 of x. So to find it algebraically, the first thing we're going to do is we're just going to write it in terms of y. That's how we're used to seeing the functions. And the next thing is just that actual definition of the inverse, which is swapping the dependent and the dependent variables. And now, because we always write the functions in terms of y equals, we're just going to follow through on the algebra and rewrite it in terms of y. Or in terms of x rather, isolating for y. Okay, the last step here, a nice quick way to get rid of the 9/5 is just multiplying by the reciprocal. So if we multiply by 9, we're going to divide by 9, and if we divide it by 5, we're going to multiply by 5. And of course, we'll have to do that to that whole other side. So this is now gone. Our function is now in terms of y equals, and this is 5/9, and this, when we multiply it out, ends up being minus 17.8, rounded at 17.777, okay? And then finally, we're just going to express it in that inverse notation. Okay, so this is the equation for this inverse line right here, okay? And now, if we substitute 68 into here, then your answer, hopefully you can answer that, will be 20. A couple of properties of the inverse function. So any function that we draw, so all the x and y values will always be swapped, and it will always be symmetrical about the line of y equals x. The scale is a little bit not perfect here, but it's always going to be symmetrical about this line. So this line of y equals x. Okay, so that symmetry, the scale here is not even, but that symmetry will always be maintained. Okay, and all the x and y points are swapped. Just a couple of quick examples here visually. As you can see, these are the functions and the inverses, and there's the line of y equals x. Always symmetrical, and any point that you take on this line, so if you take the point here of 1, 2, this point will be on 2, 1 on the inverse, right? That is the definition of inverse. This is the inverse of the parabola. Be careful, this is not a function, just a relation, but nonetheless you see this inverse relationship here. Yeah. So if we take a point of 2, 4, then on the inverse that point will be at 4, 2. Okay. So in the do now, you're going to go through the algebraic process of finding the inverse and then sketching both of those. And that's inverse functions. Bye.